and welcome to Synthesized. With this demo, you'll see how you can use the Synthesized SDK to improve model performance with upsampling. The story begins with me, a data scientist at a bank, and I'm working on a model to predict credit delinquencies. The dataset I'm working with only has a 5% delinquency, so I'm going to use Synthesized to create a safe, compliant dataset used to build an accurate and robust credit delinquency model. The Synthesize SDK will model the deep statistical data set to generate completely new data points. The data can then be manipulated or rebalanced for the purposes of improving my credit prediction model. Since delinquency data is dependent on different customer attributes, which are often sensitive in nature, it's not possible to easily gather the data for model training. I can't use production data without some sort of anonymization, and that often reduces data quality. And traditional normalization techniques are not fully risk-free either and may also result in poor signal-to-noise ratio. So unlike those techniques, the Synthesize SDK maintains full data privacy compliance. It complies with regulations like GDPR, CCPA, and HIPAA. Using synthesized data prevents the possibility of linkage attacks, and it does this by creating brand new data that looks and feels just like the original data, but without the presence of any of the original data points. With this demo, we're going to see how synthesize can be used to augment and rebalance a data set to improve my credit risk model. Let's get started. The first step, let's load the data set. You can see that the credit data set I'm using contains a mixture of categorical and continuous variables. The next step is to split the data set into train and test to make sure that when we evaluate the model, we evaluate it on unseen and unbiased data sets. So let's get to it. The high-dim synthesizer is the main object that is able to learn and generate some data, but to do so, it needs a data frame meta. This data frame meta that is extracted by meta extractor contains all meta information about the data set. So just with these two commands, we're able to generate a synthesizer object. Now let's learn the data. With another simple command, synthesize learn, you can learn the whole data set. This process takes a few minutes, so I'm going to stop here and jump forward a bit. Great, the synthesizer has finished learning the data. Now let's generate some new data. In this case, I'm going to generate 100,000 rows, although I could generate as many as I want. Let's look at the first 5 rows of this data set. As you can see, to the naked eye, they look very similar to the original. But now let's assess the quality of the generated data. We have the assessor object that helps us to look a bit deeper into data and look at how good the synthesizer did its job. First of all, let's look at the marginal distributions of the columns in this data frame. You can see here in pink the original distributions, and in blue the synthesized distributions, and you can see that the distributions are very similar in both data sets. Now, as a data scientist, why do I want a data set? To train a model. So let's do it. Let's train our model on the original and synthesized data sets. Okay, we can see that the ROC curve looks very similar for the original and synthesized data. Even the area under the curve is very similar in both cases. The precision recall curve, it has a small difference, but again, they look very similar. Also, something very important in a case like this is the confusion matrix. You can see in both cases the classifier made the same mistakes and performed very similarly in both cases. But the data set still has some problems. If we plot the target distribution, this serious delinquency column, it's a very highly imbalanced data set, which you can see causes a lot of problems. And you can see that one of the biggest problems is that it has a lot of false negatives. So how to solve that? Luckily, we have another object called the conditional sampler that will help us deal with imbalanced data sets. We'll be able to generate a new data set that's not imbalanced anymore. To do that, we import the conditional sampler we generated from the synthesizer, and it's already trained, and we define the marginals. In this case, I want to set the target distributions to 0.5, so I now have 50% of the classes delinquent and 50% non-delinquent. That's how I define the marginals. And now I can generate 50,000 rows with these marginals. It's as easy as that. Now let's look at the data we just generated. I'm going to plot the distributions for delinquency. In the previous case and the current case, you can see before, yeah, the distribution was very unbalanced, but now we were able to generate a 50-50 distribution. So how did that help us? Let's train again the logistic regression and perform the classification task and see how the metrics change. We can see in terms of ROC curve or area under the curve, the numbers didn't change much. But the PR curve, although it looks quite similar, you can see that the F1 score, and it was 0.27 in the original data, it went up to 0.32 in the synthesized data. Well, that's a that's a pretty good improvement. But what's more important, let's look at the confusion matrix again. Maybe now the number of true positives is a bit smaller. It went down a little. But what's far more important is that we were able to half, even more than half, the number of false negatives. So the message for you, delinquents, we will catch you next time. Thank you for checking out how the Synthesized SDK can help improve your data science projects with high quality synthesized data. If you have any questions, please feel free to get in touch.